And welcome to the second video in Chapter 9. So now we're going to be talking about how we maintain hormonal levels. So in general, all hormonal levels are going to be controlled by negative feedback. So negative feedback, we're going to oppose the change and bring us back to our set point. There are three basic mechanisms that activate hormone release. So we have hormonal control. This is the most common form of endocrine release. And then we have humoral control, which is changes within our blood levels of some chemicals. And then we have neural control. So when we need certain hormones, when we have low levels of certain hormones in our system, the most common way that we bring our hormone levels back up is through hormonal control or hormonal stimuli. So in this case, the hypothalamus, which is the master of the endocrine system, I mentioned that before. So the entire endocrine system is controlled in general by the hypothalamus. The hypothalamus then releases activating or inhibiting hormones, stimulating or inhibiting hormones. And these hormones then are released into our system, and they might stimulate another hormone. Okay, so here we have the hypothalamus receiving a signal that, hey, we need some type of a hormone. And so that causes the anterior pituitary gland. So the hypothalamus then sends a chemical stimulus to the anterior pituitary. Anterior pituitary gland then releases a hormone that stimulates the thyroid gland. So this might be thyroid releasing hormone, which stimulates anterior pituitary to release thyroid stimulating hormone, which then stimulates the thyroid gland to release thyroid hormone, or corticotropic releasing hormone, which stimulates the anterior pituitary to secrete adrenocorticotropic hormone, which stimulates the adrenal cortex to release cortisol. Or we might need a sex hormone. And so then we release some type of sex hormone releasing hormone, which stimulates our anterior pituitary to release follicle stimulating or luteinizing hormone, which then stimulates our gonads, either testes or ovaries, to release the sex hormone. So that's how hormonal release works. Humoral release, then, it occurs when we have changes within our blood of certain ions. And so when we think of humor, think of body fluids, and the main one that we talk about is blood, okay? And so if we have low levels of, say, blood calcium, which is what this is showing, then that's going to stimulate the parathyroid gland to increase blood calcium levels. If we have high levels of blood calcium, then that will stimulate our thyroid gland, which is this organ. So these are parathyroids on the back of the thyroid, to release calcitonin. Insulin and glucagon also are controlled via humoral stimulation. Then we have neural stimulation, not stimuli or stimulation, I don't care. So the nervous system will send signals, and again, this is from the hypothalamus. When we enter into the sympathetic system, so our fight or flight system, immediately a signal moves from the hypothalamus into the medulla of the adrenal gland, so adrenal medulla, and we release epinephrine and norepinephrine, which then sends a flood of epinephrine, norepinephrine into our blood, and it helps us to either fly, so run, or fight, whatever is occurring, depending. So now we have, and I already talked about these, but we have multiple endocrine organs. So all of these are part of our work in the endocrine system. The hypothalamus, like I said, is the master of the entire endocrine system. The pituitary gland is the master endocrine gland. The pineal gland, a little tiny gland sitting in the epithalamus. The thyroid gland here. Parathyroid gland, which is on the back of the, or I'm sorry, thyroid gland here, and the parathyroid gland, which sits on the back of the thyroid. So they're showing the thyroid gland, and then they're showing the parathyroids on the anterior aspect, but actually parathyroid glands are on the posterior aspect of the thyroid. The thymus, which is in the mediastinum of the thoracic cavity. In an adult, it's actually more or less just a fatty tissue. It's very large in infants and young children. The adrenal glands, which sit on top of the kidneys. The pancreas, which it sits right below, so inferior, the stomach. And then we have our gonads, either ovaries or testes, depending, okay? So I mentioned this before, but I'll mention it again. Some of our glands have purely endocrine functions, while others have mixed functions. So they might be endocrine and exocrine. So examples of purely endocrine organs are the anterior pituitary gland, the thyroid gland, the adrenal gland, and the parathyroid gland. These glands are ductless glands, so they don't release chemicals to any certain duct. They release their chemicals directly into the blood or lymphatic fluids. Your pancreas, your gonads, these have both endocrine and exocrine functions. So they release materials via exocrine secretions to a lumen, and they release endocrine secretions to the blood. Whoa, what is up with that? Hold on. Let me fix that, and then I will come back. Hey, it looks much better now. I don't know what happened. It was like I pushed everything up here. So at this point, if you're looking at the study guide, we have answered what is direct gene activation, what is the second messenger system, and actually those were answered on the last one too. What are the 3 stimuli for controlling and releasing of endocrine hormones? Which glands of the endocrine system are considered endocrine only and which are considered exocrine and endocrine? Oh wait, I'm not stopping yet. It's too early. So let's go to the next slide. So now let's talk about the pituitary and the hypothalamus. The pituitary gland is a P-shaped gland, and it sits, it hangs at the base of the brain from the hypothalamus, okay? It sits in a region of the sphenoid bone known as the sella turcica. So hopefully you remember the sella turcica when we talked about the skeletal system. There are 2 lobes within the pituitary gland. There's an anterior pituitary and a posterior pituitary. The anterior pituitary is glandular tissue, so it produces and secretes its own endocrine hormones. The posterior pituitary is completely nervous tissue, so it has no ability to produce endocrine hormones. It is nervous tissue, but it does store hormones and secretes them when stimulated. So it stores hormones produced by the hypothalamus and then secretes them when stimulated. The pituitary gland itself is typically called the master endocrine gland, but remember, I mentioned, and I always mention, that the hypothalamus is the master of the entire endocrine system. The pituitary is just the master endocrine gland. It's like he's the king, but he's the king of all, and the pituitary gland is the king of a small realm, maybe. That's how you can think of it, okay? So let's look at the pituitary gland and the hypothalamus a little closer. So if you see, here's the hypothalamus, and this entire structure is your pituitary gland. You have an anterior and a posterior lobe. Posterior is nervous tissue, remember. The anterior is completely endocrine. So up here we have cells that produce hormones. These cells then send the hormones to the posterior pituitary for storage and secretion. And so both oxytocin and antidiuretic hormone are produced by the hypothalamus, stored in the posterior pituitary, and then released when needed. The anterior pituitary is completely endocrine, and so it produces its own hormones. The hypothalamus produces releasing and inhibiting hormones that stimulate the anterior pituitary to release their hormones. There we go. So, as I just said, the posterior pituitary doesn't make hormones. It just releases hormones. The two hormones that are released are oxytocin and antidiuretic hormone. Oxytocin functions in uterine contractions during labor, during pregnancy, labor, and delivery. Uterine contractions during your period to help in releasing that tissue from the endometrium. And helps in releasing milk, the letdown reflex, during breastfeeding. Antidiuretic hormone functions on the kidneys, and it stimulates the production of more aquaporins, which then allow for water to be reabsorbed by our system, so we don't lose as much water. And I just talked about this, but now you can see the words. Stimulates contractions during labor and breastfeeding and pregnancy, causes milk ejection or that let-down reflex in women as well. Antidiuretic hormone inhibits urine production, so it promotes water absorption by producing more aquaporins. This allows us to decrease the amount of water we lose, especially if we are in a situation where our body is getting dehydrated. Interesting fact, little tidbit of information. Alcohol inhibits antidiuretic hormone secretion, which is why you have to pee more often when you are drinking. And also why you become so dehydrated that you have a hangover the next day. So the anterior pituitary then produces a lot of hormones. All of these hormones are protein-based hormones, and these hormones are either going to affect other endocrine organs, so follicle stimulating, luteinizing, thyrotropic, and adrenocorticotropic hormone. These are all called tropic hormones. Tropic hormones are hormones that stimulate another endocrine gland to secrete their hormones. The other two, growth hormone and prolactin, they stimulate other cells, not endocrine cells, to do their jobs. Growth hormone acts on muscles and bones, stimulates metabolism, whereas prolactin acts on your mammary glands to produce milk. And so here you can see the different activities of each of the hormones. So here we have growth hormone, acts on your bones and muscles, stimulates the activity, so stimulates growth and development of the body, all right? Here we have prolactin, stimulates mammary glands to produce milk so that when the baby is born, you have breast milk available. We have then 4 thyrotropic hormones, or not thyroid, I'm sorry, 4 tropic hormones, follicle stimulating hormone and luteinizing hormone. These are both what we call gonadotropic hormones because they act on your gonads. Gonads are your sex organs like testes and ovaries. And they stimulate the secretion of hormones as well as the secretion of egg or sperm. Thyrotropic hormone, also known as thyroid stimulating hormone, stimulates the thyroid gland to secrete thyroid hormone. Thyroid hormone is your metabolic hormone. It's actually a series of 2 different hormones that I typically just put together as one, okay? And then we have adrenocorticotropic hormone, which stimulates the adrenal cortex to secrete cortisol. So all pituitary hormones are protein-based hormones, so they have to use the second messenger system, and they're all regulated by negative feedback. I just talked about each of these. Growth hormone has a major effect on growth of the body, helps us in determining the final body size, can help in building up proteins, causes fats to be broken down for a source of energy. Prolactin stimulates the production of milk when you are getting ready to have a baby and then following childbirth. We don't really know if prolactin has a function in males. We're not sure about that one. Gonadotropic hormones, follicle stimulating hormones, stimulates development of the follicles in the ovaries, which hold our eggs, and sperm development in testes. And then luteinizing hormone stimulates the or triggers ovulation in females and stimulates the release of estrogens and triggers the release of testosterone in males. Thyrotropic hormone, also known as thyroid stimulating hormone, influences growth and activity of the thyroid gland. So it works growth and activity of the thyroid gland. The thyroid gland is your major metabolic gland. So thyroid hormone acts with your growth hormone in increasing metabolism. Adrenocorticotropic hormone then stimulates the adrenal gland to release the cortisol from the adrenal cortex. The pineal gland is a little tiny gland that a lot of people forget about. It's just a tiny little gland found in a region of the brain called the epithalamus. And it secretes melatonin. Melatonin is needed to help us maintain normal sleep-wake cycle. So as the sun goes down and the environment becomes darker, we start releasing melatonin. This is our normal kind of determiner of when you go to bed and when you get up. When the sun starts to come up, that's when you stop producing the melatonin and you can get up, well, with the sunrise, right? So people sleep during the dark times and they wake during the light times. It also is known to, or it is thought to kind of control the desire of reproduction and producing the offspring and everything else, like that biological clock. But that I don't know as much about. I know the main job is a sleep-wake. Melatonin is also known to, in the wintertime, be increase in production because it's darker out. And when you have an increased production of melatonin, this can actually lead to a disorder known as seasonal affective disorder, or SAD, and that can lead to seasonal depression. So too much melatonin is not good for you, and the best way to not produce too much melatonin is to get out into the sunlight when it is like a winter season and there's less sun. Get out in the sunlight when there is sun so that you have that sunlight and your body doesn't produce too much melatonin. I'm going to stop here because I just noticed that I went for 20 minutes and that's a long video. So I'll start on the thyroid gland in the next video. Bye.